I'm going to show you two different methods of factorising the more difficult type of quadratic. That is the one that's non-mnemonic. In other words, it has a number bigger than 1 in front of the x squared. Now this complicates things because not only do we have to think about the factors of the n term, 10, we've also got to figure out the factor pairs possible for the 6. And then we've got to also, on top of all of that, figure out all the different combined ways that those factor pairs could be rearranged. So I start as usual by putting my x, and I have my lines representing the inside and outside multiplication, and then I list the factor pairs of the n number 10. Now I have to start to consider the factor pairs of the front multiplication for 6x squared, but I've got to list them both ways. So the two factor pairs for 6 are 6 and 1 and 3 and 2, and I have to list them in both possible ways. Once I've listed all of those factor pairs out the front both ways, and the ones at the end just the one way, I can start systematically working my way through. So across the top I go 2 times the x, follow the line down, times the 1 gives me 2x, and on the bottom I do 3 times the x, follow the line up to the 10, so 3 times 10 is 30x. So I've got my 2x and my 30x, and I can work my way through all of those different factor pairs to make all of the possible combinations that could possibly happen for my inside and outside multiplication. So I can go across and get my next line would then be the 2 and the 3 at the top, the black ones, multiplying by the 5 and the 2. And then I can start working through that red pair of factors, the 3 and the 2, and so on. So I'm taking each of the four factor pairs that are out the front of the x, and for each one of those pairs I've got to multiply it by the 10 and the 1 and the 5 and the 2. So that gives me a total of 8 different possible factor pairs to search through. The next thing that I need to do is I need to figure out which one of these factor pairs could possibly give me negative 11 as a result. So we can see there that we've got a negative 10 on the end. That must mean I had signs were different. One of them is going to be positive, one of them is going to be negative, to add together to give me negative 11 in the middle. So which one of these pairs would add together to give me negative 11? And you can probably see there that the second one in is going to do the job for us. 15 and 4, if I put a negative with the 15, then those two would add together to give me negative 11. So now I need to know which factor pairs gave me the negative 15 and the positive 4x. For that to happen, it was in the black pair, so I have to use the 2 and the 3 out the front, and I have to use the 5 and the 2, and to get negative 15 I'd have to put a negative with the 5, and to get positive 4x I'd have to put a plus with the 2. Don't forget that we have to follow those inside-outside lines across for the multiplications. So to figure out the final answer, I now just read straight across the top line 2x minus 5, I should say, and reading straight across the bottom row I get 3x plus 2. So there are my two brackets. So this method involves quite a lot of writing, but it does list out every possibility, and it does work quite well once you get used to it, but you have to be organized and neat with your writing. The second method is decomposition. Decomposition decomposes or splits the middle term. So for the same problem, we start off by looking at multiplying the 6, the first number that's in front of the x squared, by the last number, the constant term, minus 10, and then we try and look for factor pairs of that multiplication. So I've got negative 60, I want factors of 60. So I list out all of the factors of 60, all of the factor pairs, 1 times 60, 2 times 30, 3 times 20, and so on, until I get everyone listed. And the question I've got to ask myself is which pair of these is going to add together to give me negative 11. Hopefully you can spot them. It's that pair there, which is positive 4 and negative 15. That's the pair that will add together to give negative 11. So we use this to then split the negative 11x into two separate terms, both involving x. So we're going to use this to split this into the two parts. That is, we're decomposing the negative 11x into 4x minus 15x. You might recognize that from the last method, that this was the inside and outside multiplication, the 4x and the 15x, that gave us the negative 11x. Okay, so far we've multiplied 6 and 10 together, we got 60, we listed the factor pairs, we figured out which of the factor pairs are going to add together to give us negative 11, and we've used that to split the negative 11x. What next? Now what we need to do is to take the first two terms and take out a common factor, and then take out a common factor from the second two terms. When we do that, you might notice that what's left inside the bracket is the same thing in both of those pairs. So I get 3x plus 2 being left behind in both pairs. So in case you can't see what I've done there, I've got the 6x squared plus 4x. I'm just ignoring the rest of it. I'm finding a common factor between those two things of 2x, and I'm dividing 6x squared by 2x. That's where I get the 3x from. And I divide the 4x by 2x, which just gives me 2. Then the second pair of numbers on the second line there is negative 15x minus 10. I look for a common factor between those two terms, which is negative 5. I take the negative 5 out and divide negative 15 by negative 5, which leaves me with positive 3x, and then I divide the negative 10 by negative 5, which gives me positive 2. And if you are worried about making any mistakes, then this is a good point to just in your head expand that bracket again and make sure that it takes you back to what you started with. So now 3x plus 2 becomes a common factor. We can take that out, bring it out the front, and we're left with 2x minus 5 in the second bracket. And I'm finished. I've now factorized that using the decomposition method. This method, you can do a lot of this in your head, and this bit here on the page is really the only writing you need to show, so that's a bonus for it. To me it makes a little bit less sense, and I find it a bit more difficult. But anyway, here is the summary of the decomposition method. It might be a good idea to write this down in your notes. So the first step is take out any common factor that is in the line. Secondly, find a factor pair of the a times the c, that is the number in front of x squared times the constant term in the end, and find that factor pair that will add to give you b. Use that factor pair to decompose your bx, split it into two x terms. Factorize the first two terms, and then factorize the second two terms and take out the common expression. Alright, well let's do a bit of practice. Let's try a problem using these steps. So we want to factorize this one here. You might like to pause the video and then go through step 1 through step 2, 3, 4 and check that you can get to the answer. And in a minute I'll go through the solution. Right, so the first step is to take out any common factor. Hopefully you spotted that there was a common factor of 2. So we just write a 2 out the front and then divide each of the terms by 2. Now we move on to the next step, which is to take that number in front of x squared, the 10, multiply it by the constant term on the end, the negative 3, and that'll give us negative 30. We're going to be searching through the factor pairs of 30 so that they add together to give us negative 1. So multiply AC, multiply the front number, which was 10, by the last number, minus 3, and search through the factor pairs of that to find out which ones add together to give us our middle term, which was negative 1 in our problem. So our 10 times minus 3 was 30, and the factor pairs are 31, 15, 2, 10 and 3, and 6 and 5. For them to add together to give negative 1, well, if we use the 6 and the 5, that'll work out if we put a negative with the 6 and a positive with the 5. Groovy McDoovy. So we move on to the next bit, and that is to use those factor pair minus 6 and 5 to decompose or split our middle term into two separate x expressions. So we're going to rewrite it, and we're going to replace that minus x with minus 6x plus 5x. In other words, the decomposing part, step 3 of our decomposing method. So now I write my front term and my end term, and instead of writing the middle term of minus x, I replace it with the minus 6x plus 5x, which of course both add together to give you minus x anyway. So I haven't changed the value of the expression. The multiplying 2 is just dagging around out the front. Alright, on to the next bit. We're up to step 4, to factorise the 2 halves. That is, take the first 2 terms, find a common factor and bring it out, and the second 2 terms, find a common factor and bring it out. So 10x squared minus 6x, we're just looking at that, finding a common factor of 2x and bringing it out. Second one, well, a bit tricky. There's not really a common factor, but we can just put plus 1 out the front. And that allows us to get that common factor of 5x minus 3. That can come out the front and create a second bracket of 2x plus 1. 2's still dagging around out the front. So now I have finished. I can say that 20x squared minus 2x minus 6 is equal to 2 times 5x minus 3 times 2x plus 1. So that's your decomposition method. So decomposition method and the first method that I showed you are identical really at the end of the day. They're just different methods of setting out your working, different ways of showing your inside and outside multiplications and figuring out which multiplication would give you that result. 2 different ways of doing it. Doesn't matter which one you use, it's completely up to you. I think it's probably a good idea to try each method once or twice just to get your head around how they work and see which one suits you better. I guess this one's my preferred method. I find this one easier to my brain, my visual brain, on laying out the problem, but some people get a bit confused with the going across the lines and so on as well, and find the other method easier. Completely up to you how you do it. If you have a look on YouTube, you'll find these methods and others explained 100 times over on different videos, so don't be afraid to jump online and just search for factorising quadratics.